Hello friends, we have completed the exercise 3.1, 3.2. Now we'll start the new topics, inverse trigonometric function. I will explain all the theoretical part first of all, solve examples and all the problems from the exercise 3.3. Now let us start the inverse trigonometric functions. Now let's learn inverse trigonometric function. Inverse sine function. Consider the function sine minus pi by 2 to plus pi by 2 to minus 1 to 1. It can be verified from the graph that with this domain and the range, it is 1, 1 and onto function, and therefore the inverse sine function exists. It is denoted by sine inverse of minus 1 to 1 to minus pi by 2 to plus pi by 2. For x belongs to closed interval minus 1 to 1, and here theta belongs to the closed interval minus pi by 2 to plus pi by 2. We write here sine inverse of x is equals to theta if sine theta is equals to x. Here theta is known as the principal value of sine inverse of x. For example, sine of pi by 2, we know that sine pi by 6 is equals to 1 upon 2, where 1 upon 2 belongs to minus 1 to plus 1 closed interval, and pi by 6 also belongs to minus pi by 2 to plus pi by 2 closed interval. And therefore sine inverse of 1 upon 2 is equals to pi by 6. The principal value of sine inverse of 1 upon 2 is pi by 6. Just we have find out the value of principal values in exercise 3.1. Similarly here we will find out the principal values of inverse trigonometric function. However, though sine of 5 pi by 6 is also 1 upon 2. Okay. We cannot write that is a sine inverse of 1 upon 2 is equals to 5 pi by 6, because that is 5 pi by 6 does not belongs to minus pi by 2 to plus pi by 2. 5 pi by 6 is 160 and minus 90 to plus 90. 5 pi by 6 does not belongs. Okay, and therefore we cannot write sine inverse of 1 upon 2 is equals to 5 pi by 6. That's why you have to remember this range, that is minus pi by 2 to plus pi by 2. It is a range of sine inverse of x. Next, sine of minus pi by 4, that is equals to minus 1 by root 2, where minus 1 by root 2 it belongs to closed interval minus 1 to plus 1, no problem. And minus pi by 4 belongs to also the closed interval minus pi by 2 to plus pi by 2. And hence these two conditions are satisfied, and that's why sine inverse of minus 1 by root 2 is equals to minus pi by 4. Next, the principal value of sine inverse of minus 1 by root 2 is minus pi by 4. Note that sine of sine inverse of x is equals to x, and here this x belongs to the closed interval minus 1 to plus 1, and the sine inverse of sine of y is equals to y, where the y belongs to minus pi by 2 to plus pi by 2. Now the next, inverse cosine function. Consider the function cos of 0 to pi to minus 1 to plus 1. Okay, the cosine is defined from this closed interval 0 to pi to closed interval minus 1 to 1. It can be verified from the graph again that it is again 1, 1 and onto function. Therefore, its inverse function exists. It is denoted by cos inverse, that is raised to minus 1. And thus cos inverse of minus 1 to plus 1 to 0 closed interval 0 to pi. Here for x belongs to closed interval minus 1 to plus 1 and theta belongs to 0 to pi. We can write here cos inverse of x is equals to theta. Okay, and is the cos of theta is equals to x. Cos inverse of x is equals to theta. That is a cos of theta is equals to x. Here theta is known as the principal value of cos inverse of x. Next, for example, cos of pi by 4. We know that cos of pi by 4 is 1 by root 2. And again, this 1 by root 2 belongs to closed interval minus 1 to plus 1. And also pi by 4 belongs to 0 to pi. And that is cos inverse of 1 by root 2 is equals to pi by 4. The principal value of cos inverse of 1 by root 2 is pi by 4. Next, though the cos of minus pi by 4 is 1 by root 2. Okay. We cannot write that is a cos inverse of 1 by root 2 is equals to minus pi by 4, as minus pi by 4 does not belong to this interval. It is from 0 to pi. Again, note that cos of cos inverse of x is equals to x for x belongs to closed interval minus 1 to plus 1, and cos inverse of cos of y is equals to y for y belongs to closed interval 0 to pi. Next, inverse tangent function. Consider the function tan minus pi by 2 open interval minus pi by 2 to plus pi by 2 to r, where r is a set of real number. It can be verified from the graph again that it is a 1 1 and the onto function, and that's why therefore its inverse function exists, and it is denoted by tan inverse like this. And thus tan inverse is defined from r to open interval minus pi by 2 to plus pi by 2. Here x belongs to set of real number and theta belongs to the open interval minus pi by 2 to plus pi by 2. We can write tan inverse of x is equals to theta if tan theta is equals to x. For example, tan of pi by 4 is 1. We know that, where 1 belongs to set of real number and pi by 4 belongs to minus pi by 2 to plus pi by 2. Therefore, tan inverse of 1 is equals to pi by 4. That is the principal value of tan inverse of 1 is pi by 4. Next, tan of tan inverse of x is equals to x, for x belongs to set of real number. And second, tan inverse of tan of y is equals to y, for y belongs to the open interval minus pi by 2 to plus pi by 2. Inverse cosine function. Okay, consider the function cosec minus pi by 2 to plus pi by 2 minus 0 to r minus open interval minus 1 to plus 1. It can be verified from the graph that it is again 1 1 and the onto function, and therefore its inverse function exists, and it is denoted by cosec inverse. And thus cosec inverse defined from set of real number minus open interval minus 1 to plus 1 to closed interval minus pi by 2 to plus pi by 2 minus 0. For x belongs to r minus in bracket minus 1 to plus 1 and theta belongs to closed interval minus pi by 2 to plus pi by 2 minus 0. We can write here that we write cosec inverse of x is equals to theta if cosec theta is equals to x. For example, it's clear that cosec pi by 6 is equals to 2, where 2 belongs to set of real number minus 1 to plus 1, and pi by 6 belongs to minus pi by 2 to plus pi by 2 minus 0, and hence cosec inverse of 2 is equals to pi by 6, and that's why the principal value of cosec inverse of 2 is pi by 6. Again note that cosec of cosec inverse of x is equals to x for x belongs to set of real number minus in bracket minus 1 to plus 1. Cosec inverse of cosec y is equals to y for y belongs to the closed interval minus pi by 2 to plus pi by 2 minus 0. Now the inverse second function. Consider the function say 0 to pi minus pi by 2 to r minus open interval minus 1 to plus 1. It can be verified from the graph again. That is, it is a 1, 1 and onto function. Therefore, the inverse function exists and it is denoted by sec inverse, and thus sec inverse of r minus open interval minus 1 to plus 1 to 0 to pi minus pi by 2 for x belongs to r minus open interval minus 2 plus 1 and theta belongs to the closed interval 0 to pi minus pi by 2. We write sec inverse of x is equals to theta if sec theta is equals to x. For example, sec of pi is minus 1, where minus 1 belongs to r minus in bracket open interval minus 1 to plus 1, and pi belongs to 0 to pi minus pi by 2. Therefore, sec inverse of minus 1 is pi. Therefore, the principal value of sec inverse of minus 1 is pi. Again note that sec of sec inverse of x is x for x belongs to r minus open interval minus 1 to plus 1, and sec inverse of sec of, I write here, sec inverse of sec of y. Okay, sec inverse of sec of y is equals to y for y belongs to 0 to pi minus pi by 2. Okay. Now the inverse cotangent function. Consider the function cot of 0 to pi to set of real number. It can be again verified from the graph that it is 1, 1 and the onto function. Therefore, its inverse exists and it is denoted by cot inverse. Cot inverse defined from r to 0 to open interval 0 to pi. Here x belongs to set of real number and theta belongs to open interval 0 to pi. We can write here cot inverse of x is equals to theta if cot theta is equals to x. For example, cot of pi by 3 is equals to 1 by root 3, where 1 by root 3 belongs to set of real number and pi by 3 belongs to the open interval 0 to pi, and hence cot inverse of 1 by root 3 is equals to pi by 3, and therefore the principal value of cot inverse of in bracket 1 by root 3 is pi by 3. Again note that cot of cot inverse of x is x for x belongs to set of real number, and cot inverse of cot of y is equals to y for y belongs to the open interval 0 to pi. Now the principal values of inverse trigonometric function. The following table shows the domain and the range of all inverse trigonometric function. The value of the function is the range is called the principal value of the function. Okay, these are the principal values. Sine inverse is defined from minus 1 to closed interval minus 1 to plus 1, minus pi by 2 to plus pi by 2. Cos inverse minus 1 to plus 1 closed interval to closed interval 0 to pi. Tan inverse defined from set of real number to open interval minus pi by 2 to plus pi by 2. Cosec inverse defined from r minus open interval minus 1 to plus 1 to closed interval minus pi by 2 to plus pi by 2 minus 0. Sec inverse defined from r minus open interval minus 1 to plus 1, 2, 0 to pi minus pi by 2. Now the examples. Find the principal values of the following. First example, sine inverse of minus 1 by 2. We have sine inverse of minus 1 by 2. Again I will repeat here, sine inverse of minus 1 upon 2. We have sine inverse of minus 1 upon 2, where minus 1 upon 2 belongs to the closed interval minus 1 to plus 1, and minus pi by 6 belongs to minus pi by 2 to plus pi by 2. Therefore, sine inverse of minus 1 by 2 is equals to minus pi by 6. And therefore, the principal value of sine inverse of minus 1 by 2 is minus pi by 6. And again, we know that where is the value of, if it have this, the x-axis and y-axis. Okay, the minus pi by 2, it's here in this quadrant. Okay, and here you must have here, its value is a minus pi by 6. In the fourth quadrant, sign is a negative, and hence its principal value is a minus pi by 6. Cos inverse of root 3 by 2. We have cos of pi by 6 is equals to root 3 by 2, where root 3 by 2 belongs to minus 1 to plus 1, and pi by 6 belongs to the closed interval 0 to pi. Therefore, cos inverse of root 3 by 2 is equals to pi by 6. Okay, and hence the principal value of cos inverse of root 3 by 2 is pi by 6. Cot inverse of minus 1 by root 3. We have the cot of 2 pi by 3 is equals to minus 1 by root 3, where minus 1 by root 3 belongs to set of real number, and pi by 6 belongs to 0 to pi. Minus 1 by root 3 belongs to set of real number, and 2 pi by 3 belongs to 0 to pi. And here is the principal value of cos inverse of minus 1 by cot inverse of minus 1 by root 3 is 2 pi by 3. Next, find the values of the following. Sine inverse of sine of 5 pi by 3. Sine inverse of sine of 5 pi by 3 is equals to sine inverse of sine of this 5 pi by 3 can be written as sine of 2 pi minus pi by 3. Okay, therefore sine of 2 pi minus theta, and it will come in the fourth quadrant. Here is, it will be the 2 pi, that is a 2 pi minus pi by 3 sine. It is in the fourth quadrant. In fourth quadrant, sine is negative, and that's why here that is a sine of 2 pi minus pi by 3, and that is nothing but the minus pi by 3. Okay, or you may write it is a minus and there is never difference. Okay, you can write here minus n, or it is a minus pi by 3. Sine inverse of sine of minus pi by 3, that is a minus pi by 3. Here minus pi by 3 belongs to the closed interval pi by 2 to plus pi by 2, and hence the sine inverse of sine of 5 pi by 3 is equals to minus pi by 3. Next, tan inverse of tan of pi by 4. It's very simple. That is a tan of pi by 4. Tan pi by 4 is a 1, and we can write here that is a tan inverse of tan of pi by 4, and that is equals to pi by 4, where this pi by 4 again belongs to the open interval minus pi by 2 to plus pi by 2. Next, sine of, in bracket, cosec inverse of minus 1 by root 2. We know again that the cos inverse of minus x is equals to pi minus cos inverse of x, and therefore sine of cos inverse of minus 1 by root 2 is equals to sine pi minus cos inverse of 1 by root 2, and again the value of, that is a cos inverse of 1 by root 2 is pi by 4. Cos inverse of 1 by root 2 is a pi by 4, and if you simplify this, then you will get sine of pi minus pi by 3 is a sine of 3 pi by 4. And sine of 3 pi by 4 is 1 by root 2. Sine of 3 pi by 4. See this here. This is the, here is a 3 pi by 4. And it is a 1 by root 2. And that's why sine of cos inverse of minus 1 by root 2, that is equals to 1 upon root 2. Okay. Next, sine of cos inverse of 4 by 5 plus tan inverse of 5 by 12. Now, consider here. Let cos inverse of 4 by 5 is equals to theta and tan inverse of 5 by 12 is equals to phi. Cos of theta is equals to 4 by 5. Tan of theta is equals to 5 by 12. From this, sin theta is 4 by 5 and therefore, cos theta is a 4 by 5 and therefore sin theta is a 3 by 5. If we draw the triangle and then you will get here, that is this is the right angle triangle. Okay, this is the theta and what is the cos is the adjacent side and this is the hypotenuse. Therefore, opposite side is 3 and therefore opposite side, that is a 3 by 5. Similarly, in case of the next, which is the phi angle. Okay, this is the phi angle. Tan of phi means what? Opposite side and this is the 12. Therefore, this is the root 13. Therefore, cos of phi is adjacent side upon this hypotenuse, that is the 12 upon and 13. And hence, we have, that is a sine of cos inverse of 4 by 5 plus sine inverse of, tan inverse of 5 by 12. Okay, this is the theta and this is phi. Now their expansion, sin theta cos phi plus cos of theta sin phi, sine of a plus b. Substitute the value of sin theta from this triangle. Sin theta is the opposite side upon hypotenuse, that is a 3 by 5. 3 by 5. Next, cos phi from this triangle, cos of phi, that is a adjacent side upon hypotenuse and you can substitute its value. Cos theta from this triangle, that is a 4 upon 5. Here is a 4 upon 5. Sine of phi from this triangle, sin pi, that is the opposite side 5 by 13 and this is a 5 by 13. Perform their multiplication and then you will get 56 upon 65, that is a sine of cos inverse of 4 by 5 plus tan inverse of 5 by 12 is equals to 56 upon 65. Now the next, find the values of the following. Sine inverse of 3 by 5 plus cos inverse of 3 by 5. We have, if the value of x lies between minus 1 to plus 1, then sine inverse of x plus cos inverse of x is equals to pi by 2 and the 3 by 5 is lies between minus 1 to plus 1 and that's why sine inverse of 3 by 5 plus cos inverse of 3 by 5 and that is equals to pi by 2. Therefore, sine inverse of 3 by 5 plus cos inverse of 3 by 5. We will substitute the value of this, that is equals to pi by 2. Therefore, sine of pi by 2 means what? Sine 90 and that's equals to 1. Okay. Next problem. Cos inverse of minus 1 upon 2 plus tan inverse of root 3. Now, cos inverse of minus 1 upon 2. Now, where the cos is negative in the second quadrant and its value is 2 pi by 3. Tan inverse of root 3, it is in the first quadrant. Okay, here is in the first quadrant for the tan and tan inverse of root 3 is a pi by 3 and that's why here we will substitute the value, that is a cos inverse of minus 1 by 2 plus tan inverse of root 3 and here we substitute, that is a 2 by 3 plus pi by 3, that is a 3 pi by 3, 3 get cancelled, you will get cos of pi and cos pi is a minus 1. Now the next, if mod of x is a less than or equal to 1, then show that sine of cos inverse of x is equals to cos of sine inverse of x. We have for mod of x less than or equal to 1, sine inverse of x plus cos inverse of x is equals to pi by 2, and therefore we write here cos inverse of x is equals to pi by 2 minus sine inverse of x. Okay. Also, we know that the sine of pi by 2 minus theta is cos theta, and that's why sine of cos inverse of x. We want to find out sine of cos inverse of x. Now here we substitute the value of cos inverse of x. What is that? Pi by 2 minus sine inverse of x. Okay, sine of pi by 2 minus theta. Then it is a cos of sine inverse of x. But what is the value of? That is, this is nothing but the RHS that we want to prove. That is the cos of sine inverse of x. This is the cos of sine inverse of x, and hence LHS is equals to RHS. Now next, prove the following. Now the next problem, 2 times tan inverse of 1 by 3 plus cos inverse of 3 by 5 is equals to pi by 2. Now 2 times tan inverse of 1 by 3 is equals to tan inverse of 1 by 3 plus tan inverse of 1 by 3. And this is x and y. What is the product of x, y? That is 1 by 3 into 1 by 3. That is 1 by 9, which is less than 1. Now here we will apply the formula for tan inverse of x plus tan inverse of y. That is the tan inverse of x plus y upon 1 minus x into y. And that's why here tan inverse of 1 by 3 plus 1 by 3 upon 1 minus 1 by 3 into 1 by 3. And if we simplify this, then you will get tan inverse of 3 by 4, and that's equals to theta. Here, therefore, 3 by 4 is equals to tan theta. The value of theta lies between 0 to pi by 2. Next, sin theta is 3 by 5, and that's why theta is equals to sin inverse of 3 by 5. Now consider here, that is a 2 times tan inverse of 1 by 3. That is here, 2 times tan inverse of 1 by 3. Here we get tan inverse of 3 by 4, and that's why we are replacing here tan inverse of 3 by 5, 3 by 4, and that is nothing but sine inverse of 3 by 5. Okay, and therefore we write here 2 times tan inverse of 1 by 3. This is the nothing but sine inverse of 3 by 5, and the cos inverse of 3 by 5 is as it is, and that's why its value is equals to pi by 2. We have here pi. Okay. Now the next problem, 2 times tan inverse of 1 by 3 plus tan inverse of 1 by 7 is equals to pi by 4. 2 times tan inverse of 1 by 3, that's equals to tan inverse of 3 by 4. That we have seen in our example. Okay, and therefore 2 times tan inverse of 1 by 3 plus tan inverse of 1 by 7, and that is equals to tan inverse of 3 by 4 plus tan inverse of 1 by 7. Again the product of these two, that is a 3 by 4 into 1 by 7, which is less than 1. Again we will apply the formula tan inverse of x plus tan inverse of y is equals to tan inverse of x plus y upon 1 minus x into y, and therefore tan inverse of 3 by 4 plus 1 by 7 upon 1 minus 3 by 4 into 1 by 7. And if we simplify it, then you get tan inverse of 1, and this tan inverse of 1 is nothing but the pi by 4. Now the next is, prove that tan inverse of 1 plus tan inverse of 2 plus tan inverse of 3 is equals to pi. We use the result tan inverse of x plus tan inverse of y is equals to pi plus tan inverse of x plus y upon 1 minus x into y when the product is greater than 1. Now here the 1 and 2, these are the two numbers such that their product is greater than 1, and that's why tan inverse of 1 plus tan inverse of y is equals to, we'll apply this formula pi plus tan inverse of 1 plus 2 upon 1 minus 1 into 2, and if you simplify this, then you will get pi plus tan inverse of 3 upon 1 minus tan inverse tan inverse of 3 upon 1 minus 2. 1 minus 2 is minus 1, and overall you will get minus 3. That is a pi plus tan inverse of minus 3, and that's why tan inverse of minus x is minus tan inverse of x, and here tan inverse of minus 3 is a minus tan inverse of 3, and hence here, that is, what is that? tan inverse of 1 plus tan inverse of 2 plus tan inverse of 3 is equals to pi. Because we have started here, tan inverse of 1 plus tan inverse of 2 is equals to pi minus tan inverse of 3, and it can be written as tan inverse of 1 plus tan inverse of 2 plus tan inverse of 3 is equals to pi. Next, prove that cos inverse of 4 by 5 plus cos inverse of 12 by 13 is equals to cos inverse of 33 upon 65. Now here cos inverse of 4 by 5 is equals to theta. Suppose that. Now the value of theta is lies between 0 to pi by 2, and that's why cos of theta is 4 by 5. Sin theta is equals to 3 by 5. Okay. Cos inverse of 12 by 13 is equals to 5. And therefore, again the phi lies between 0 to pi by 2. Cos of phi is 12 upon 13. And here sin phi is equals to 5. Okay, sin phi is equals to 5 upon 13. Now the expansion of cos of phi plus theta, theta plus phi is equals to cos theta cos phi minus sin theta sin phi. Now substitute the value. Cos of theta 4 by 5. Cos of phi 12 by 13. Okay. Sin theta, the value of sin theta 3 by 5. Next is a sin of phi 5 by 13. And if you simplify it, then you get 48 upon 65 minus 15 upon 65 is equals to 33 upon 65. And hence cos of theta plus phi is equals to 33 upon 65. Also, the values of phi and theta lies between 0 to pi by 2. Okay. Therefore, if we add it, then you will get 0. Phi plus theta lies between 0 to pi. And therefore, from 1, that is a cos. That is a, here is a theta plus phi is equals to cos inverse of 33 upon 65. And hence, cos inverse of but what is the value of theta? Theta is a cos inverse of 4 by 5 and phi is a cos inverse of 12 by 13, and that is equals to cos inverse of 33 upon 65. Now we'll start the exercise 3.3. Now exercise 3.3. Find the principal values of sine inverse of 1 upon 2. Solution. The principal branch of sine inverse of x is minus pi by 2 to plus pi by 2. And therefore, let sine inverse of 1 by 2 is equals to alpha. Again, I will repeat here. Sine inverse of 1 upon 2 is alpha, where the value of alpha lies between minus pi by 2 to plus pi by 2. But we know that is the sine alpha is equals to, that is here, from here, sine alpha is equals to 1 upon 2, and we know that 1 upon 2 is the value of sine of pi by 6. And therefore, this alpha is pi by 6 and it belongs to, it lies between minus pi by 2 to plus pi by 2. And therefore, the principal value of sine inverse of 1 upon 2 is pi by 6. Cosec inverse of 2. Again, the principal branch of cosec inverse of x is minus pi by 2 to plus pi by 2 minus 0. Again, let the cosec inverse of 2 is equals to alpha, where minus pi by 2, alpha lies between minus pi by 2 to plus pi by 2, alpha is not equals to 0. Again, the cosec alpha is equals to 2 and the cosec pi by 6 is 2. It means that alpha is equals to pi by 6, and that's why the pi by 6 lies between minus pi by 2 to plus pi by 2. The principal value of cosec inverse of 2 is pi by 6. Tan inverse of minus 1. The principal branch of tan inverse of 1 lies between minus pi by 2 to plus pi by 2. Tan inverse of minus 1 is equals to alpha, where alpha lies between minus pi by 2 to plus pi by 2. Tan inverse of minus 1 can be written as minus tan of pi by 4. Again, we know the formula. Tan of minus theta is equals to minus tan theta. Using that, tan alpha is equals to tan of minus pi by 4. And here alpha is equals to minus pi by 4. And the value of this alpha minus pi by 4 lies between minus pi by 2 2 plus pi by 2. And therefore the principal value of tan inverse of minus 1 is minus pi by 4. Next is the tan inverse of minus root 3. The principal branch of tan inverse of x lies between minus pi by 2 to plus pi by 2. And that's why tan inverse of minus root 3 is equals to alpha, where the alpha lies between minus pi by 2 to plus pi by 2. Now the tan of alpha is equals to minus root 3. Again we can write root 3 is the value of tan of pi by 3. Again by the formula, tan of minus theta is equals to minus tan theta. And therefore we can write here tan of alpha is equals to tan of minus pi by 3, where alpha is equals to minus pi by 3, and this alpha lies between, that is a pi by 3 minus pi by 3, lies between minus pi by 2 to plus pi by 2, and hence the principal value of tan inverse of minus root 3 is minus pi by 3. Next is the sine inverse of 1 by root 2, and we know that it is a pi by 4, but see this here, the principal branch of sine inverse of x is minus pi by 2 to plus pi by 2. Let sine inverse of 1 by root 2 is equals to alpha, where the alpha lies between minus pi by 2 to plus pi by 2. No problem. Therefore, sine of alpha is equals to 1 by root 2, and 1 by root 2 is the value of sine of pi by 4. And that's why the alpha is equals to pi by 4. Okay. And this lies between, this is the pi by 4. Okay. This pi by 4 lies between minus pi by 2 to plus pi by 2. And hence the principal value of sine inverse of 1 upon root 2 is pi by 4. Next is the cos inverse of minus 1 upon 2. Again the principal branch of cos inverse of x is minus 0 to pi. And that's why now let cos inverse of minus 1 by 2 is equals to alpha, where the alpha lies between 0 to pi. Now the cos of alpha is equals to, from here, cos of alpha is equals to minus 1 upon 2. Again the 1 upon 2 is the value of cos of pi by 3. Again by the allied angle, that is the cos of pi minus theta is minus cos theta, and that's why cos of pi is equals to cos of pi minus pi by 3. And if you simplify this, then you will get cos of 2 pi by 3, and that's why alpha is equals to 2 pi by 3, where this 2 pi by 3 lies between 0 to pi. Therefore the principal value of cos inverse of minus 1 by 2 is 2 pi by 3. Next, evaluate the following. Again this is also simple. First, tan inverse of tan inverse of 1 is alpha, where alpha lies between minus pi by 2 to plus pi by 2. Therefore, tan alpha is equals to 1. 1 is the value of tan of pi by 4, and hence alpha is equals to pi by 4, and that's why tan inverse of 1 is a pi by 4. Next, we have the cos inverse of 1 upon 2. Cos inverse of 1 upon 2 is equals to beta, where beta lies between 0 to pi, and therefore cos of beta is equals to 1 upon 2, and 1 upon 2 is the value of cos of pi by 3, and that's why beta is equals to pi by 3, and therefore cos inverse of 1 by 2 is a pi by 3. And the last one is sine inverse of 1 upon 2. Now here sine inverse of 1 upon 2 is a gamma, where this gamma lies between minus pi by 2 to plus pi by 2, and therefore sine of gamma is equals to 1 upon 2. Again 1 upon 2 is the value of sine of pi by 6, and this pi by 6 lies between minus pi by 2 to plus pi by 2, and that's why this gamma is equals to, gamma is equals to pi by 6, and hence sine inverse of 1 upon 2 is equals to pi by 6, and that's why the tan inverse of 1 plus cos inverse of 1 upon 2 plus sine inverse of 1 upon 2, first was pi by 4, next is pi by 3, and the last is pi by 6. If you add it by using the LCM, then you will get 3 pi plus 4 pi plus 2 pi, and that's nothing but 9 pi upon 12, and that is 3 pi by 4, and hence tan inverse of 1 plus cos inverse of 1 upon 2 plus sine inverse of 1 upon 2 is equals to 3 pi by 4. Next problem, cos inverse of 1 upon 2 plus 2 times sine inverse of 1 upon 2. Let cos inverse of 1 upon 2 is equals to beta, where the beta lies between 0 to pi. But what is here? Cos of beta is equals to 1 upon 2. Again, the 1 upon 2 is a value of cos of pi by 3. And that's why the beta is equals to pi by 3, where this pi by 3 lies between 0 to pi. Therefore, cos inverse of 1 upon 2 is equals to pi by 3. Next is a sine inverse of 1 upon 2 is equals to gamma, where this gamma lies between minus pi by 2 to plus pi by 2. And that's why sine of gamma is equals to 1 upon 2. And that is nothing but sine of pi by 6. And that's why here the gamma is equals to pi by 6. And here sine inverse of 1 upon 2 is equals to pi by 6. And here cos inverse of 1 upon 2 is pi by 3. Sine inverse of 1 upon 2 is a pi by 6. What we want to find out? We want to find out cos inverse of 1 upon 2 plus 2 times sine inverse of 1 upon 2. Substitute the value pi by 3 plus 2 times pi by 6. And here you will get pi by 3 plus pi by 3. That is a 2 pi by 3. And here is the answer. Next is a tan inverse of root 3 minus sec inverse of minus 2. Now here let tan inverse of root 3 is alpha. And the value of alpha lies between minus pi by 2 to plus pi by 2. Therefore, tan alpha is equals to root 3 and tan of root, that is the root 3 is the value of tan of pi by 3. It's clear that alpha is pi by 3. And this pi by 3 again lies between minus pi by 2 to plus pi by 2. This is the first one. Next is, therefore, tan inverse of root 3 is pi by 3. Next, sec inverse of minus 2. Sec inverse of minus 2 is beta. And the value of this beta lies between 0 to pi, where beta is not equals to pi by 2. Therefore, sec of beta is equals to minus 2, and minus, that is a 2 is a value of sec of pi by 3. Again, by the allied angle, sec of pi minus theta is minus sec theta. And by using this, sec of beta is equals to sec of pi minus pi by 3. And if we simplify this, then you will get sec beta is equals to sec of 2 pi by 3. And that's why beta is equals to 2 pi by 3. And hence sec inverse of minus 2 is equals to 2 pi by 3. And hence tan inverse of root 3 minus sec inverse of minus 2 is equals to the first value of pi by 3 and the next value, that is a 2 pi by 3. And if we simplify this, then you will get tan inverse of root 3 minus sec inverse of minus 2 is equals to minus pi by 3. And hence the answer. Next is a cosec inverse of minus root 2 plus cot inverse of root 3. Again, the cosec inverse of minus root 2 is equals to alpha, where this alpha lies between minus pi by 2 to plus pi by 2. Here is alpha. Okay. Now, next is a cosec alpha is equals to minus root 2. But the root 2 is a value of cosec pi by 4. And therefore, again by the allied angle, again by the using the formula, that is a cosec minus theta is equals to minus cosec theta. And hence, we can write it, that is a cosec alpha is equals to cosec in bracket minus pi by 4. And this value of minus pi by 4 lies between minus pi by 2 to plus pi by 2. And that's why alpha is equals to minus pi by 4. Next value, that's we want to, that is, therefore, the cosec inverse of minus root 2 is a minus pi by 4. Now next, cot root 3 is equals to beta. Again, the beta lies between 0 to pi. Therefore, cot of beta is equals to root 3. But the root 3 is a value of cot of pi by 6. Okay. And that's why beta is equals to pi by 6. Now this pi by 6 again lies between 0 to pi. And that's why cot inverse of root 3 is equals to pi by 6. Now we want to find out the value of these two. Now substitute their values. Cosec inverse of minus root 2 is minus pi by 4. And cot inverse of root 3 is pi by 6. And if you simplify this or find out the LCM, then you will get minus 3 pi plus 2 pi upon 12. And that is nothing but minus pi by 12. And hence, cosec inverse of minus root 2 plus cot inverse of root 3 is equals to minus pi by 12. Next, we'll prove this following result. Sine inverse of minus 1 by root 2 minus 3 times sine inverse of root 3 upon 2 is equals to minus 3 pi by 4. Now one by one. Let sine inverse of 1 by root 2 is alpha. Alpha lies between minus pi by 2 to plus pi by 2. Therefore, sine alpha is equals to 1 by root 2. 1 by root 2 is the value of sine of pi by 4, and that's why alpha is pi by 4. And hence, sine inverse of 1 by root 2 is pi by 4. Next is a sine inverse of root 3 by 4 is beta, and the value of beta is lies between minus pi by 2 to plus pi by 2, and that's why sine beta is equals to root 3 upon 2, and that is a pi by 3, and hence beta is equals to pi by 3. Therefore, sine inverse of root 3 upon 2 is equals to pi by 3. Now, LHS, sine inverse of 1 by root 2 minus 3 times sine inverse of root 3 by 2. Sine inverse of 1 by root 2 is pi by 4. Sine inverse of root 3 by 2 is a pi by 3, and if we simplify it, then you will get pi by 4 minus pi, and that is a minus 3 pi by 4, and hence LHS is equals to RHS, and that's why sine inverse of minus 1 by root 2 minus 3 times sine inverse of root 3 by 2 is equals to minus 3 pi by 4. Next is a sine inverse of minus 1 upon 2 plus cos inverse of minus root 3 by 2 is equals to cos inverse of minus 1 upon 2. Again, consider LHS. Let sine inverse of minus 1 by 2 is alpha, where alpha lies between minus pi by 2 to plus pi by 2. No problem. And therefore, sine of alpha is equals to, again here minus 1 by 2. Again the 1 by 2 is the value of sine of pi by 6 from the table, you know, from the 11th standard. Again, by using the formula, sine of minus theta is minus sine theta, and by using that formula, sine alpha is equals to sine of minus pi by 6, and that's why alpha is minus pi by 6, where the minus pi by 6 is clearly lies between minus pi by 2 to plus pi by 2, and hence sine inverse of minus 1 by 2 is a minus pi by 6. Next is a cos inverse of minus root 3 by 2. We want to find out the value of cos inverse of minus root 3 by 2. Cos inverse of minus root 3 by 2 is equals to beta, where beta lies between 0 to pi. Therefore, cos of beta is equals to minus root 3 by 2 is equals to minus cos of pi by 6. Okay, and that's why cos of beta is equals to cos of pi minus pi by 6 by using the allied angle. Cos of pi minus theta is minus cos theta, and that's why here cos of beta is equals to cos of 5 pi by 6, and hence beta is equals to 5 pi by 6, where 5 pi by 6 lies between 0 to pi, and that's why cos inverse of minus root 3 by 2 is equals to 5 pi by 6, and the last value, which is that minus 1 upon 2. Cos inverse of minus 1 upon 2 is gamma. Okay, therefore cos of gamma is equals to minus 1 upon 2. Again the 1 upon 2 is the value of cos of pi by 3. Therefore cos of gamma is equals to, again by the allied angle, cos of pi minus theta is minus cos theta. Therefore this can be written as cos of pi minus pi by 3, which is cos of 2 pi by 3, and that's why gamma is equals to 2 pi by 3, where this 2 pi by 3 lies between 0 to pi, and hence cos inverse of minus 1 by 2 is equals to 2 pi by 3. Now we consider LHS. Sine inverse of minus 1 by 2, we know that is it is minus pi by 6. Cos inverse of minus root 3 by 2, we have calculated it. It is a 5 pi by 6. It was 5 pi by 6. Yeah. Okay. If you simplify this, then you will get 4 pi by 6. Okay. And again, their simplification, you will get 2 pi by 3. Okay. This is the 2 pi by 3. And that is nothing but the cos inverse of minus 1 upon 2. And hence LHS is equals to RHS. And hence the sine inverse of minus 1 by 2 plus cos inverse of minus root 3 by 2 is equals to cos inverse of minus 1 upon 2. Next is, okay, next is a sine inverse of 3 by 5 plus cos inverse of 12 by 13 is equals to sine inverse of 56 upon 65. Okay. Consider the first. Sine inverse of 3 by 5 is x. This is 1. Cos inverse of 12 by 5, that is y. And the last is a sine inverse of 56 upon 65, that is z. Sine inverse of 3 by 5 is x. Therefore, sin x is equals to 3 by 5. The value of x lies between 0 to pi by 2. Cos inverse of 12 by 13 is y. Then cos of y is equals to 12 upon 13. The value of y lies between 0 to pi by 2. Next is the sine inverse of 56 upon 65 is z. Then sin z is equals to 56 upon 65, where the z lies between 0 to pi by 2. Now here cos is positive, cos of x is positive, sin of y is positive. Therefore cos x is equals to in root of 1 minus sin square x. And if we simplify, 1 minus the value of sin x, 3 by 5, it's a square, 9 by 25. If we simplify it, then you will get in root of 16 upon 25. And that's why cos x is equals to 4 upon 5. Next, sin y is equals to in root of 1 minus cos square y. But what is the cos of y? It's a 12 upon 13. It's a square, 144 upon 169. If we simplify, you will get root of 25 upon 169. It's a square root is a sin y is a 5 by 13. And here, now we have to prove that x plus y is equals to z. Okay. Therefore, what is the sin of x plus y? Sin x cos y plus cos x sin y. Substitute the values. Sin x is 3 by 5. Cos y is 12 by 13. And cos x is equals to 4 by 5. That we have calculated here. Okay. Cos x is 4 by 5. Sin y is 5 by 13. And if we simplify, that is a 36 upon 65 plus 20 upon 65. And that's why sin of x plus y is equals to 56 upon 65. And that is nothing but the sin z. And hence, x plus y is equals to z. Okay. And that's why sin inverse of 3 by 5 plus cos inverse of 12 by 13 is equals to sin inverse of 56 upon 65. Now next problems are also very easy. Cos inverse of 3 by 5 plus cos inverse of 4 by 5 is equals to pi by 2. Let cos inverse of 3 by 5 is equals to x. Therefore cos of x is equals to 3 by 5. Again x lies between 0 to pi by 2. Okay. As cos x is equals to 3 by 5, therefore sin x is also positive. Therefore sin x is equals to in under root of 1 minus cos square x. That is in root of 1 minus 9 upon 25. If you simplify, you will get root of 16 upon 25. That is equals to sin x is equals to 4 by 5. And hence x is equals to sin inverse of 4 by 5. It means that the cos inverse of 3 by 5 is equals to sin inverse of 4 by 5. Now consider LHS here. Okay. Consider the LHS. Cos inverse of 3 by 5 plus cos inverse of 4 by 5. Now replace here cos inverse of 3 by 5 is sin inverse of 4 by 5. And hence here the sin inverse of x plus cos inverse of x is equals to pi by 2. And hence the here is a pi by 2. And that's why the cos inverse of 3 by 5 plus cos inverse of 4 by 5 is equals to pi by 2. And hence it is proved. Next is a tan inverse of 1 upon 2 plus tan inverse of 1 by 3 is pi by 4. Again consider the LHS. By using the formula. What is that formula? Tan inverse of x plus tan inverse of y is equals to tan inverse of x plus y upon 1 minus x into y. By that formula, here you will have tan inverse of 1 upon 2 plus 1 by 3 upon 1 minus 1 upon 2 into 1 by 3. And if we simplify it, then you will get tan inverse of 3 by 2, 3 plus 2 upon 6 minus 1. That is tan inverse of 1. And the tan inverse of 1 is pi by 4. And hence, tan inverse of, here is 1. Tan inverse of tan of pi by 4. 1 means what? Tan of pi by 4. And tan inverse of tan of pi by 4 is pi by 4. And that is nothing but the RHS we want to prove. And hence LHS is equals to RHS. And that's why tan inverse of 1 upon 2 plus tan inverse of 1 by 3 is equals to pi by 4. यामध्ये फक्त हा फॉर्म्युला इथे तुम्हाला अप्लाय करायचा. नेक्स्ट इज 2 times tan inverse of 1 by 3 is equals to tan inverse of 3 by 4. Again here the LHS 2 times tan inverse of 1 by 3. 2 times tan inverse of 1, tan inverse of x means what? Tan inverse of 2x upon 1 minus x square. Similarly here tan inverse of 2 into 1 by 3 upon 1 minus 1 by 3 bracket square. And if we simplify it, then you will get tan inverse of 2 by 3 upon 1 minus 1 upon 9. And after their simplification, tan inverse of 2 by 3. This is 8 upon 9 and it will become 9 upon 8 multiplied and reciprocal. Okay. Therefore, tan inverse of 2 by 3 into 9 by 8. If you simplify it, then you will get 3 by 4. Okay. And here is a 4 and here is like this. You will get tan inverse of 3 by 4 and hence LHS is equals to RHS, that is 2 times tan inverse of 1 by 3 is equals to tan inverse of 3 by 4. Okay, now the next example. Tan inverse of cos theta plus sin theta upon cos theta minus sin theta is equals to pi by 4 plus theta, where theta belongs to open interval minus pi by 4 to plus pi by 4. Here the LHS tan inverse of cos theta plus sin theta upon cos theta minus sin theta. Now here we can write it, that is a divide numerator and the denominator by cos theta. Here cos theta upon cos theta plus sin theta upon cos theta upon cos theta minus sin theta upon cos theta. And this is nothing but 1 plus tan theta upon 1 minus tan theta. And this is nothing but the tan inverse of 1 means what? Tan of pi by 4 plus tan theta upon 1 minus tan of pi by 4 into tan theta. And this is nothing but the expansion of tan of pi by 4 plus theta. And tan inverse of tan of pi by 4 plus theta is pi by 4 plus theta. That is the tan inverse of tan theta is theta. And hence that we want to prove, that is pi by 4 plus theta. Now the next is tan inverse of in root of 1 minus cos theta upon 1 plus cos theta is theta by 2. It's a very simple example. We know that 1 minus cos theta upon 1 plus cos theta from the 11th standard. 2 sin square theta by 2 upon 2 cos square theta by 2. 2 get cancelled, you will get tan square theta by 2. Taking the square root on both sides, you will get root of 1 minus cos theta, root of 1 minus cos theta upon 1 plus cos theta is equals to root of tan square theta by 2. The root of tan square theta by 2 is a tan of theta by 2, and hence LHS is equals to tan inverse of root of 1 minus cos theta upon 1 plus cos theta is equals to tan inverse of tan of theta by 2. Okay, the value of this is a tan of theta by 2. Tan inverse of tan of theta by 2 is theta by 2, and that's why tan inverse of tan of theta is theta. And that is why we want to prove that it is a theta by 2. And hence LHS is equals to RHS. And that's why the tan inverse of root of 1 minus cos theta upon 1 plus cos theta is equals to theta by 2, where theta belongs to minus pi to plus pi. And hence we have completed the chapter trigonometry, that is exercise 3.1, 3.2, and this was the 3.2. For the trigonometry, you have to practice more and more to get the perfect in the trigonometry. Now we'll see in the next video. Till then, goodbye.